Alrighty, hello everyone. As you can probably tell, I'm extremely sick at this point in time and won't make it in to tutor you. It is Wednesday. So, what I'm going to do is I'm going to tell you all the things here that I would tell you in that tute, which is probably better because now everyone gets the same learning. Rightio. So, the thing that you had to do for this tute was this exercise thing, which I need to explain in a little bit more depth because it was kind of difficult to understand. So, what you're looking at here in this bottom bracket is a three-dimensional object. So it has depth here, right? So there's width at that point, and so you got your two pedals, which are going to kind of like apply a torque, and that applies kind of, you know, out here and back there, and that's why you will have a couple going down on this node and up on that node, right? And then you also have this chain ring, which will put into tension the chain and put into compression this thing, that member. Yes. And then this force, the one that's confused everyone, is the force pushing the bike forward. The force pushing the bike forward. So, if you have 1400 watts of power applied at the crank, and we assume that our drivetrain is 100% efficient, that 1400 watts will be transferred through our gear ratio to the rear wheel. This final solution that I gave here is wrong, by the way. It's a lot less than that. Through your gear ratio, so you take your torque and then you divide it by the gear ratio, because that's how gear ratios work. And then you have your rear wheel, which changes the gear ratio again. It interacts with the road, and that is an external force being applied onto the bike. Now that's important because inertial forces are real forces. So this force that's accelerating the bike is a real force that's being applied to the mass of the rider and the mass of the bike, and it has the capacity to apply stresses to our system. So think about, for example, like a drag racing car. The stresses applied due to that acceleration, which is insanity how fast those things accelerate, that's a real force which applies real stresses to the frame and needs to be taken into account in our FEA. In our case, it's really minuscule because cyclists can't really put out that big a force to accelerate themselves. But it is still worth considering. Right, so we're looking here, and you've got a power, and you've got to find these forces. So how do you do that? Well, apparently this was not well-known fact, but if you take a power and you divide it by the rotational velocity in radians a second, you get Newton meters of torque. You have one lever arm, two lever arms, that'll give you one force and two forces. When you do the pedals, divided by two, because there are two pedals, right? Then when we get back here, you take this force, or no, just take this torque, which comes out at 133.6 Newton meters. Take that torque, and then divide 10.5 millimeters by 126 millimeters to get your gear ratio. Okay, that gear ratio is important because it reduces the amount of torque that we have. Right, so then you're going to get the torque around this rear wheel, and then you need to think about the lever arm that's applying that torque to convert it into a force. Now that lever arm is simply the radius of the wheel. Which in this case is 0.311 meters. So you take that torque and you divide it by the radius of the wheel, and you will get the force that the bike is applying on the road, therefore the force that the road is applying on the bike. It's all very nice and fun, kind of Newton stuff. Right, so now we've done that. Let's think about how to apply that to our frame. So we know we know that we want to have this thing in compression. How do we achieve that? A lot of people will tell me that you apply a force back there and a force forward there. That's kind of not the philosophy of FEA. That's not really how FEA works. You can't apply two forces and tell them to kind of counteract each other. Well, you can, but it doesn't really work. Trust me, I've tried it. What you do is you take the force in this place. We put it on that node, or that node, I suppose, and you fix the other node. Fix the other node. So what I want you to do is, from this solution, right, we need to think about how the bike's going to deform, how the stresses are going to go through the frame, what's going to happen to this structure, and how we can achieve that in FEA. Right, so let's think about the wheels. So we got one wheel here, and then our fork comes down, and our other wheel's here. That caused some confusion, apparently.